for those that are just joining in, I'll reiterate what we just said. We're going to go over what we did on Tuesday, because there wasn't practicals, or should I say there wasn't enough practicals. Some people were lost and a couple people had issues. So I have prepared materials that we're going to use for practicals. I tried to, I tried to save time, and I decided to spend a lot of time on just doing explaining instead of practicals, because the first time I tried to do practicals, that took a lot of time. So I think what I'll do now is, I'll explain the concept and then we get into the code. Sorry, excuse me. Seems I have a cough. All right, so let me share my screen. Um, share Okay. This is open. This should be closed. Yes, this is supposed to be okay. Okay, please let me know if you guys can see my screen now. Can you see my screen? If I, or Raphael, if you can see my screen, just, thumbs up, give a reaction, or okay, is the chat open? Okay, let me see. Okay, yes, we can. All right, then let me move on. So I have switched over to our GitHub repo. Can you guys like confirm that you can see that as well?
Yeah, we can.
Okay, all right. Thank you. So I'll paste this in the chat. Sorry about my cough. Yeah, this is the repo. I'll paste this in the chat. So if you head over here, you should be able to see this intro to Langchain, um, intro to Langchain output parsers, and then you can just click on this. And to run this, you can just click on open in collab. For those that missed it, that missed on Tuesday, I kind of like showed the way you can run this in Google Colab. Just copy this, and how did I do it that day? Lord, remind me. Yeah, copy it, go to Google Colab. Let me use this Colab. Is this it? Yeah. And then you just click on GitHub, load from GitHub. Just make sure you type this GitHub, then enter the GitHub URL, paste it, and press enter, and that should load it for you. So yeah, that's basically it. Okay, so let me kick off with my presentation. No, present. All right, we're good to go. Um, So welcome back, everyone. It's glad to have glad to have you guys here once again. And the approach this time around is going to be different from Tuesday. Tuesday, I tried to do an overview with hopes of saving time, and I kind of left out all of the practicals. So what I do is now is explain the concept and then we do the practical. I hope that's cool with everyone. So if you have any question at any point in time, drop your drop it in the chat. Raphael is on the call, Ifan is on the call. I believe Sai is on the call as well, so they will help out with that. All right, let's move on. So Langchain, we've spoken about Langchain. Let me bring this out here so that it's a different tab on its own. Maybe should I have, okay. All right. So yeah, we've spoken about Langchain. Was okay. This is me, your lead, the bootcamp lead, and also I'm Ebuka Chukwudi. You can call me Ebuka as well. I'm NSK.AI's lead. I'm also this bootcamp's lead. So let's get into it. So Langchain, as I've written here, Langchain provides tools for streaming AI workflows and enhancing productivity. So developers can leverage Langchain for building complex applications with ease and efficiency. It's flexible and it has a very extensive documentation. So there's sufficient guide for using Langchain. And yeah, let's get into it. So if you're on the GitHub, I hope so if you're on the GitHub, you should see this, the intro to Langchain. Just click on the intro to Langchain and it should take you to Google Colab. All right, so I'll start with the beer, without Langchain. Then we get into Langchain. And I'll try to do this as quickly as possible. So I'm going to be using Grok. For those that don't have Grok, I mean, yes, someone told me that they tried to use Gemini on Tuesday when they were walking after the lecture, and I think they said they ran out of credit or responses after five responses. So I'm going to be using Grok. It's free, and yeah, I don't think there's any limit on it so far. So, and if you're not in the last class, you can get a free API key from Grok. Just go to console.grok.com. Go to console.grok.com or drop that in the chat. I'm not seeing the slide. Someone said I'm not seeing the slide. We are not seeing your presentation. Oh, I'm so sorry. I guess it has to be. So let me share my screen again. It should have been because I was because I opened this in a different. So let me share my entire desktop.
We
So
can
that's
see it
why.
though.
Could you see the slides when I was sharing the slides? Can you
Yes,
see can you see the slides now?
yes.
All right, all right, all right. Okay then. So yeah, so you go to console.grok.com. I've pasted that in the chat. Yeah, I've pasted it in the chat. See where they say API keys. Come here, create an API key. If you create this API key, I think you won't be able to use it after. I mean, you won't be able to see it again after you've created it. So yeah, these are the ones, the past ones I've created. And this is the one I used for that Mark project. All right, let's get on with it. So yeah, this is it. Get your Grok API key and then tag along. So yeah, I'm going to install Grok, the Grok SDK. They also have documentations on how to start up with Grok, quick starts. They'll tell you to set your Grok API key in your terminal, in your environment. I mean, using this using this environment variable, if you are not going to be using this environment variable, that means you have to explicitly, either way, you still need to explicitly call it here. So it's not, it depends, it's up to you. So yeah, I'll install Grok, and then this was OpenAI. Okay, there's a reason why I installed this. So I'll hide whatever I get. So next thing you have to do is you set your environment variable. If you're in Google Colab, if you're not running this locally, set your environment variable. I dropped a note on how to go about setting your environment variable because it's a bit tricky here. So you click on this key icon here. So when you click on it, you click on add new secrets here. Yeah, see it's add new secrets here, and then enter the name of the variable like I've done here, enter the value. You don't have to click save. All you have to do is just make sure that it's accessible to this environment. That's all. You just have to toggle this place. You don't have to save it. It will save automatically. So sorry about that. When you do that, next thing is you import user data to get it from the environment. This is how we do things in this is how they do things in Google Colab. In your local environment, it won't be the same. And when you're writing a Python code, it won't be the same. All right, so next. So this is a basic grok statement. So what's going on here? This is without Langchain. So if you notice, there's nothing about Langchain here. So I'm importing the operating system from Grok, import Grok. The clients. So yeah, I'm just setting the clients Grok, setting my API keys, and yeah, I'm trying to initialize a conversation, and this is the message that is receiving. The role is user, content, what is Langchain in one line. This is the model I'm using from Grok. Remember I said Grok is an AI inference. It's not exactly an LLM like GPT. And this is the line of code that will bring out my response. So let's run this and see what we get. What is Langchain in one line? It gives me a response here. Langchain is an open source, blah blah blah. So now let's try this. Let's use ChatGPT's OpenAI's SDK, OpenAI's API in essence. And according to Grok's documentation, if you look at it, they said they are compatible with OpenAI, and this is the code that they wrote. And if you look at my code, you'd see it's exactly the same thing with what they have. However, if I should run this code, it's going to break. Yeah, it's going to break. And if you check it, this is exactly what it's going to have. So this is one of the advantages of using Langchain. You don't have to disturb yourself with now. I now have to start going through OpenAI's documentation. Okay, how do OpenAI use their API and all of that? You don't have to do that when you're working with Langchain. So let me hide this. So yeah, the Langchain architecture. This is where we go back to my slides. Architecture of Langchain. So first of all, let me read what I have here. Langchain has a modular architecture designed to keep your AI apps clean and flexible. The core layer, Langchain core, defines the basic building blocks like prompts and models. Other packages like Langchain community, and Langchain OpenAI, and chains, tools, and integrations on top of that. Let's use this diagram, to make it more illustrative. So I hope you can see my blue mouse, hovering over my screen. So if you look at this diagram, we have on this side, we have what we call integrations. And inside here, we see Langchain OpenAI, Langchain Postgres, Langchain Anthropic. We have Langchain core here. And we have Langchain, and we have Langchain community here. We have Langgraph, Langsmith, Langserve. So what is Langchain Core? So Langchain Core, like it says, is the core of Langchain. So it's where all the, so to speak, the foundational classes are defined. So all the base models are defined inside Langchain Core. So everything built in Langchain, they have dependencies, they draw dependencies from this Langchain Core. And above Langchain Core is Langchain. And this Langchain core is where all of the chains. So you need to install this to be able to use chains in Langchain. That's it basically. And Langchain community, sorry, give me a minute.
We can't see the slide.
You can't see the slide. Okay. All right, let me just switch. Let me change. Let me switch to share my entire desktop. So let me know. Can you see the slides now?
Yes.
Oh, okay. Okay. Thank you. All right. So as I was saying, okay. All right. So as I was saying, this is what, so sorry that you could not see the slides initially. Oh, I see a lot of people were in the waiting room. Okay, and a good number of people have joined at once. All right. I haven't gone so far. For those that have just joined, we're still into Langchain. We're going over what we did on Tuesday, and we're doing it with practicals now with code. We've explored how do I put it now? One of the cons of not using Langchain, and we just did a code demo. So now I'm talking about the Langchain architecture. You might, I don't know, you might, for those that know Langchain, there might be other things you might call all of these, maybe Langchain system or whatever, but on Langchain website, they call it the architecture. So Langchain has different parts. They have the integrations part. This integrations part are the wrappers around your popular uh, are the wrappers around enterprise, around organization, and around enterprise solutions. So like OpenAI, like Anthropic, like Postgres. So instead of me, what I did, where is that code? What I did here, where I installed OpenAI SDK so that I can use OpenAI API. And also, yeah, I installed Grok. And instead of doing all of this here, Langchain kind of like have wrappers around all of this. So I don't have to bother myself about this. All I have to do is just install the wrapper they have around Grok. And it's pretty easy. There are a lot of pros who were using it. And at the core of everything in Langchain is the Langchain core. So this is where all of the base classes are. The base classes, the base models, every other thing here, they draw one or two dependencies from this place. Langchain, this is where all of the chains, you need this to be able to, use the Langchain expression model. Sorry about that. So you need this to sort of like use the Langchain expression model and the rest. Okay. Then we have Langchain community. You see, it's also, it's kind of like just dependency or yeah, to Langchain. So what is this Langchain community? So in Langchain, there are some external tools that you might know of that have been incorporated into Langchain. So take, for example, PDF readers. So take, for example, as people are complaining about being in the waiting room, Raf, are you on the call with me? Okay. So we have take for example, let me go back. Take for example PDF loaders. PDF
Sorry,
loaders like
Ebuka. Sorry to interrupt, Ebuka. Could you make me host so I can see people in the waiting room?
okay. Let me find you in the chat. Participants, Raphael. More. I hope you're the one that made the host now. Are
Okay, thank
you
you. Thank you.
all right? All right, thank you, Ralph. Okay, so back to what I'm saying. So take for example tools like for those that know Python or for those that write Python and you've had to work with maybe a PDF before, you have some PDF loaders. Or take for example those that are into web scraping. So you have things like a Beautiful Soup and all of that. So Langchain, they kind of like incorporate that, but it's not maintained by Langchain. So it's maintained by the community. Langchain is open source and it's maintained by, developers. So they kind of like incorporate all those external tools that we use in our, day-to-day coding into this Langchain community. All right, let's move. And yeah. I hope I covered. Okay, yeah. And this, okay, so Langsmith is an observability tool. We'll be covering that upper week. So we have the team from Langchain. The team from Langchain. They're going to be giving us a lecture specifically on observability, but that's in the advanced part. So that's in 2 weeks. And we also have LangGraph. So LangGraph is what we use to build agents. We'll learn about this towards the end. LangServe is part of LangChain. They use it to, like, as it says, to like serve APIs for your LLM applications. So let's move on. I hope that's clear with you guys. So because you might want to install something in LangChain, you might want to use a tool in LangChain, and you see you're doing pip install Langchain community, pip install Langchain, pip install Langchain core. You're still doing pip install Langchain, and you might be wondering, why am I installing all these things? Can't I just have everything in one go? I just wanted you to know that they are separate abstractions. All right, let's go. So now, key components of Langchain. I'll start with the LLMs and prompts. So we already know the LLMs, the chat GPTs, and we have the prompts. So we talked about prompt templates in the last class on Tuesday, but I'll go over it again. And there's code there, thankfully. So if you are on the GitHub collab, I believe that you're following through. And for those that just joined in, I will paste the link again. Go to this GitHub repo, go to nsk.ai GitHub repo. You will see this Jupyter Notebook, Intro to Langchain. I pushed it in the chat again. Put it in the chat one more time for those that joined in. So just go there and load this. All you have to do is tap on this place, open in Collab, and then you have what I'm seeing right now. All right. So back. So we have the LLMs. So that is the main engine behind your AI application. It's not an AI application if it doesn't, have an LLM or a machine learning model, so to speak. And then we have the prompts. So that is, what you use to interact, how you use to control and to orchestrate your AI application. We have the chains, which is like the core of Langchain, and then we have memory, so vector databases. Vector databases, that's where we store vectors. We're going to review that as we go. We also have agents and we have the documents loaders and other utilities. So document loaders and the utilities, all of them reside in Langchain community. All right, let's move. So yeah, this is the core of what Langchain is about. This is what Langchain is about at its core. We have where you feed it your documents. In this diagram is a PDF. I mean, not just Langchain, RAG as a system. It chunks those PDFs, it embeds those PDFs, it stores those embeddings into a vector store. And then when you come and you're trying to get information about your documents, it also embeds your question, and then it does what we call a semantic search. So a semantic just means similarity. So it does like a comparison search to see, okay, what document is similar in this vector stored to the embeddings that are stored. What documents, in the vector store is still similar to the question I'm asking. And that's it about Langchain. So we have prompt templates next. So prompt templates streamline the process by providing structured inputs for language models. They enhance consistency and clarity, making interactions more effective and manageable. Let's go to the code. So yeah, we've covered Langchain architecture. I hope you guys are following, and I hope you're learning something as well. Now we're getting into Langchain proper. So I pip install Langchain for Grok. And then I also so I've installed Langchain. I showed you, where Langchain fits in it's because of this installation I can use chains exactly. So sorry guys if we go over an hour. I hope you bear with us, and I'm very sure that you get good value from going over an hour. We just have to do it. Okay then. So I've installed Langchain Grok. It's one of those enterprise wrappers I was talking about. So yeah, I do from Langchain Grok import chat Grok. Then import OS. I'm using this OS to get my API key from the environment of this Google Colab. And here is where I initialize my LLM, my Grok model. So you just see it's easy. Yeah, I just say LLM equal to chat Grok. And then I decide what model I want to use, and then I put in my Grok API, and then I press enter. If I also, okay, yeah, I'm also getting there. So, okay, yeah, also, I just wanted to show you how easy and why you should be using Langchain. So, yeah, I installed Gemini's API, and so, sorry, I'm installing Gemini with Langchain. That's the package. If you read this text here, you kind of like understand. I put it here for those that might be confused about the syntax. And here is where I'm getting, the API key from my secrets, from my environment. At the start of this, there's where you can get that. All right, so I run this. So if you noticed, yeah, I said LLM equal to this. Yeah, I already defined my LLM to be chat group, but yeah, in this line I'm just swapping it out. And if I do response.llm.invoke, what is Langchain if it was a bedtime story in one sentence? It is expected to give me a response. And yes, it did give me a response. So I can choose to go with Gemini. I can choose to comment this out and then decide that, okay, I want to use Grok instead. And you see, it's just easy like that. I just swapped one of the, so I didn't have to like go through any documentation and all of that. And if I come down here again and do llm.invoke, I should also get a response. It's the same methods if you look at it, the same llm.invoke. It doesn't matter whether I'm using OpenAI or not. Do you understand? So now we're going into prompts templates. So yeah, you can write your basic. So prompts, you know how what prompts are. We did a class on prompt engineering last week. Watch our YouTube video if you missed that. Translate the following sentence to French in one line, how I use today. So this is basically like both the instruction and what I want out of the LLM. And if you do this, it would work. But one thing you need to understand is that this is not efficient enough, because and what if I want to pass in history? I want to pass in some more context. It's not efficient enough to be doing this through just this one line, and I'm trying to form, even if I'm using formatting strings in Python, it's not efficient enough. And that's where prompt templates come into play. So look at this prompt template. All you have to do is import from langchain.prompts, import prompt template. So we have prompt equal to prompt template dot from templates. And here I set my prompt. Excuse me. You are Naruto Uzumaki. I believe everybody here already knows I'm a big fan of Naruto. You're Naruto Uzumaki from the Hidden Leaf. You are bold, energetic, blah, blah, blah. Always speak in an enthusiastic, slightly brash tone and end your responses with believe it. Respond to the following sentences as Naruto. And then you see this placeholder here, sentence. Now, this now makes it easy for me to swap things out. It makes it easy for me to swap things out. So yeah, I say, okay, so I've defined my prompt here, and I come to this line. Let me run this code, define my prompt here, and I say, oh, formatted prompt is equal to prompt.format. And I just, this thing I use here, this same placeholder I use there, you can just set it here. If I name this to, let's say, Emmanuel, what I will be doing here is Emmanuel. Excuse me. And it's whatever I pass in here is going to replace what is here. It's going to, it's going to replace this placeholder here. So let's run this. I hope it will break, but yeah, it won't, I'm sure. Oh, it broke. Why did it break? Same sentence. Where? I want to find out what the issue is, but I believe. Okay. Yeah, it's run now. I'm so sorry, guys, about my cough. So yeah, it's run now. So yeah, the placeholder was a manual. Okay, so what happened was I needed to rerun the cell after I changed the placeholder name. So yeah, it's a manual, and yeah, I'm just saying, no, a manual is equal to what advice would you give someone who feels like giving up? And I want to print the format. So if you look at this place here, we have your Naruto, blah, 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 and then we have the placeholder. But here, it's already formatted as what advice would you give to someone who feels like giving up? And this is just going to pass into the LLM easily. And when I run this, and same thing here, LLM.invoke formatted underscore prompt, and so you see it gives me the AI message, and inside, so it gives me an object, literally gives me an object, and inside this object, I'm so sorry guys, I need to off my AC. But yeah, before that, it gives me this object that has this AI message, and if you check right here, you should see things like input tokens. So we talked about tokens last year. We had Mr. Gamma who took us on that. Output tokens. It gives us more information than when, than when we were using, just the grok and all of that. It gives us more information. And if you want to get the particular response that it gives you, you have to, you have to store this inside a variable llm.invoke. You pass in your formatted prompt, and then you do response.content so you can, assess what you have here. And if I run this, yeah, you see, whoa, you're feeling like, so this is the response. Sorry to stop. And yeah, this is the response we get, and this is the response we get, and you see it's formatted. It's not gibberish like here. So yeah, guys, please give me just 10 seconds. Let me switch off my AC. All right, I'm back. I hope you guys can see me. Hi, guys. Raf, are we still there?
Yeah, we see.
All right. Sorry about that, guys. All right. So I hope you're following along. So if you have any questions, please drop it in chat. And I hope this particular lecture is also more explanatory than what you had last on Tuesday. Now, moving ahead from prompt templates, we have what we call messages. So we have prompt messages. So there are three types of prompt messages. We have the system message, we have the human message, we have the AI message. So the system message says the behavior or background. It says the behavior of your AI, of your LLM. So someone asked on Tuesday, what's the difference between system message and AI message? And when I get to AI message, I'll answer that question. And then human message is your input. So it's the question you're asking. It is what you write inside the chatbot for ChatGPT. AI message is basically the response you get back from your LLM. System message is the message you use to like give your LLM the mindset it's supposed to use to answer you to the instruction that is supposed to use to guide it. All right, and then let's just get into code immediately. So I also wrote like the same thing I wrote here. So let me run this. And for system message, if you also notice, look at it, we are importing system message and human message from Langchain.schema. We'll come to where we'll still use Langchain community. And so if we do this from Langchain.schema, the messages import system message, human message. This is basically going to format. So it's going to be an array. So if you notice that, where did we use it? Just know that one of the formats of input is true messages. So it's going to be an array, and then this is going to format it to tell you that okay, it's going to give your LLM more context, so to speak. Remember how I spoke last week that context is important to get the best out of an LLM. More context. So this is going to format it. Let's look at what the value of this message is actually. So if I come down here and put message, let's look. Oh, it's breaking. Messages is not defined. Okay, I haven't run this field yet. So if I run that, so you see it's an array with the system message object and the human message object. And then it takes it like this, feeds it into your LLM. So here we have the normal LLM.invoke to get a response. And Langchain handle, so you don't even have to worry about, all of these, removing the content and all of that, all these additional parameters, or, Langchain handles everything under the hood for you. So if I just do LLM.invoke the message, what was the question here? Who has the best jollof rice in Africa? And this, if I was to get, so let me put this inside a response equal to this, and then I print this. Sorry, wrong cell. And then I print this. Response.content. So he said, oh, Ghana is often credited. Shout out to the guys from Ghana with jollof rice, blah blah blah. You get my point, right? Using this system message to kind of like give your LLM more context is different from when you are doing, when you have everything inside one prompt, like we had it here. You are Naruto Uzumaki and all of is different from it. Like this feels like, oh, this is a one prompt. But this is different. It's like, hey, take your instruction, then now take my inputs. Now that I've told you who you are, what you're supposed to be doing, take my input. And that's what, that's what it is about. So this was another example I wrote. Your helpful assistant that must answer in one line, always lead with the human's name. Hello, my name is Emmanuel. Hi, Emmanuel. I guess you're from Ethiopia. Tell me a one-liner joke about, and so this kind of like simulates an interaction between the AI and the human. So if you do this, run this, we have, and yeah, it's just mixing both words. So if you go through this notebook, is self-explanatory. I want us to move fast. I'm not moving as fast as I would have loved. So it's just self-explanatory. I believe so far I've been doing well with explaining this. So now we move to the core of Langchain. We have chains and runnables. So chains in Langchain are a sequence of steps that combine multiple components like prompts, language models, and output parser into a single reusable workflow. So chains in Langchain is what takes, it kind of like orchestrates your whole process from your inputs into all of the processing that goes without your inputs down to your output. And we have runnables. Runnables is runnables are the building blocks in Langchain designed for flexibility and composability. A runnable is anything that takes an input and returns an output in Langchain. Anything at all that takes an input in Langchain and returns an output is in Langchain, and in Langchain is a runnable. And they have if you look at I wrote, they have they are implemented through the runnable interface, and they have 3 standard methods. So every runnable has 3 standard methods. They have the invoke, and we've been using the invoke a lot. They have the batch. So what does the batch do? The batch kind of like helps you, is used to process more than one input at the same time. So multiple inputs, multiple outputs. And then the stream is what you have on ChatGPT, where, or all these AI models where the output is coming out in bits, in chunks, so to speak. And examples of runnables. We have runnable lambda, we have runnable sequence, we have runnable map, we have runnable parallel. Before I get into the code, and I'll run through the code as quickly as possible, I can see that a lot of time is going. I want you to understand that there are a whole lot of runnables. So there isn't just these 4. There are so many that you can cover. Remember on Tuesday I said there are a lot of tools on Langchain that you can't possibly know everything offhand. The only thing is when you want to build something, just browse. Oh, is there something that Langchain? I'm trying to do this. How can I do this with Langchain? So just browse, because they love runnables. I can't even count how many, and I haven't used all of them. All right, so let's move to runnables. So if you go to the repo, you should see runnables and chains. So let's go to runnables. We run pip install Langchain, do the same thing, get your environment variable, install grok, get your environment variable, and here is where we do what we call chaining. This cell I use it to express what a chain is. A chain in Langchain is just this. So look at what I highlighted here. This is a chain, and what makes it a chain? It is the prompt. Then this pipe operator is called Langchain expression language, basically. But this is that in the past there were ways they kind of like wrote Langchain's chains, but that has been depreciated now. But this is the normal method. So when you see something like this, it means whatever gets into here, the output from here is passed to this person, and the output from here is passed to this person. So what's going on in this cell? So here I'm defining my charts, my prompts templates. I'm defining my LLM. I'm using Grok and I'm using the Llama model, and I'm also defining my output parser. And this is where I define my chain. So we have the prompts, the LLM, the output parser, and we have results. The result is equal to chain.invoke. So it's because of this. So remember, all of these are runnables. I mean, importing them like this, they are runnables. And they all have, and especially when you compose them together like this, they have this invoke property. They also have the batch property. They also have the stream property. And if you see here, so this input language, it was defined here in this prompt. And you just look at something. So this is where the prompt is. And here I'm saying chain.invoke. This input language, I'm putting it here English. Look at where it was defined here at the start of the chain. And just here I have to like define a dictionary and then assign the value to it. And Langchain is going to handle everything, like assigning, oh, this English should replace this output language Swahili should replace this, and the text hello how are you should replace this human text. And if you run all of that, what does it says? You're a helpful assistant that translates inputs to outputs. So hello, how are you? Is Jambo Missouri Sana Asante. I hope that's how they say it in is it Senegal or Kenya that use it? Yeah, Kenya. All right, sorry about that. So so yeah, that's it about chains. They are very simple. They are, I mean, very basic. Nothing more to it. Now we have other runnables, and so we are moving to runnables. And runnables just kind of like help you. They are like building blocks. They kind of like help you orchestrate your LLM applications for different purposes. So let me start with the first one. I believe I deleted the text that's supposed to have been on top of here. There's supposed to be a text about Runnable Lambda. So what does Runnable Lambda do? Runnable Lambda simply takes a Python function that is not part of the Langchain ecosystem, and then it turns it into a runnable in Langchain that now has the .invoke, .batch, and .stream methods. So what did I do here? So I defined my chat prompt templates. Once again, in Naruto, there's something in particular I did here. Always talk like Naruto and include these emojis in your responses. So this is, believe it, Kurama, ramen. This also, I think, is that ball, cheese balls they used to eat. And then, yeah, I defined my LLM. I defined my output string parser. But then look at something here. When I built that rag, Fabrizio rag, this thing that I demoed before, there's no time I would have loved to demo it again. But when I built it, there was an output, the AI was talking, so it's response. But if you looked at the response, some of the response, there were emojis inside the response. But one thing that you would have noticed, is that it didn't respond with, it didn't say anything about the emoji. So for those that might want to visit it and try it out, this is the site. Look at it here. You have to start it up with Streamlit stuff. You have to start it up, but I'm not going to do that. I don't have time for that. So what I did basically was whatever output I got from the LLM, I used a function, a Python function to clean it up, basically to remove emojis, so that I can take that raw text and pass it to the service provider, which is Deepgram, that was providing text to speech, that was in charge of the offer, so that when he's speaking, he's not going to be saying muzzle emoji or that type of thing. I basically cleaned it and I did a regex, and this was the function basically that cleaned it. And for me to pass this into my Langchain's chain, I decided to convert it into a runnable, so that it can be part of my chain. And this is where runnable Lambda comes in. For those that know Python, they know what Lambda is already. So basically, you just wrap it around your Python function, and then you get the runnable Lambda. And you get a runnable from it, and then you pass it in your prompts, this thing, and if you run this, you should not see any emojis. But if I should remove this last part, that is a runnable, that was clearing, you should now see emojis. So that's one of the ideas of runnable Lambda. Transfers a this thing, an LLM, sorry, transfers a Python function into a runnable in Python. So we have runnable sequence. This is simple. I didn't even bother to import it. It's the same thing as a chain runnable sequence. Just From one runnable, the input of one runnable is the output of one runnable is the input for the next runnable, like that until you get, sorry about that, until you get to your final output. Then we have the runnable parallel. So this is used when you want to run more than one function concurrently. So you want to run more than one function at the same time. So, and then get, it will return its input in a dictionary, in one dictionary for you. So here I have this runnable lambda that, is supposed to print out, here is a joke. It's supposed to return, here's a joke about X, here's a poem about X. And then I pass it through the runnable parallel. I just say joke. This joke that I'm defining here is going to be the name of the property when it comes out as an object. And if I run it, I should, and it's the same dot invoke. The runnable map is quite different from the rest. Runnable map is quite different from the rest in the sense that you define different runnables, and then you want to use different runnables on one input. That's the idea. Probably you want to use, for whatever reason you might want. So what did I do here? What I did is I used this, there's this custom function that returns the custom prompts depending on the input, and then I did a runnable map so they all have their own chain. So each of these runnable have their own chain, and I did a runnable map. So it's supposed to translate whatever input I give it into the language I want. So you have the one for Swahili, it's the same chain. The only thing is that the language is changing. You have the one for Amharic, that's from Ethiopia. You have the one for Wolof from Senegal, for Yoruba, Igbo. And if I run all of this, the sentence I'm passing in is make the most of your youth. It's probably going to cap a lot, but and if I run all of that, I should see. So in Swahili, make the most of your youth is Pungunza. I'm so sorry, I won't even. Yeah, so that's the idea of runnables basically. So moving on, let's move on to output parsers in Langchain. So we've seen one already. I'm so sorry guys for all of the cough. I honestly don't know where they all came from. So let's move on to output parsers. So we have, let me run this while all of this is coming up. You can go back here and you should see it. Output parser is in the root. It's not in any of these folders. Is in the root of the GitHub repo. And you can fork it as well. You can give our GitHub repo a star. I don't know why I can't say star here, but yeah. All right, so let's go to the output parser. So we have used the string output parser. That's one that we are all familiar with. The string output parser basically returns a string type, for whatever you get out of your LLM. So if I run this is the typical chain, but this is the output parser we're using, string output parser. So tell me a one sentence summary of the book, book title, whatever. And this is the book. So you see now, so yeah, I'm printing the type. You see the type is a string. So when you always want your output to be in string, you use the string output parser. If I was to remove this and run this again, you should see that big object that says, so you see content and you see the type is different. It's a type of, it's a class type, but that string output parser kinds of helps us clean things up. So you see, and you see, so this next line, this is not part of the output, I beg your pardon. I'm just, printing out the type for you to see that it is a type of string. So this is the output pro. Then we also have the JSON output parser. For a good number of us that program, what we use is, we use a lot of JSON. And when you're working with LLMs and you want to use your output to be in JSON so you can work on that JSON, you can also do that with large language models. So all you have to do is define the parser and say, oh, your parser is the JSON output parser, and define your prompt here. I'm saying extract the main character and its actor's name of the movie title and all of that. So I define my parser here. This is the JSON output parser. I pass it into this place. And when I run it, what do I have? So the input I'm giving, movie title, Hancock 2008, format instructions. So this is typically going to tell it, oh, return, this format instructions is typically going to tell it, it's going to add extra instructions to your LLM. So we can take a good look at it in the next line, but I just want to show you, that the output is going to be, so you see the main character of the movie is John Hancock, the actor's name is Will Smith, and if you look at it, type of output is dict, and if I do B and I check this, you see the other instructions is adding to this input to guide the LLM's output. So if I do parser.get information, return a JSON object. This is very simple. It's telling it to return a JSON object. I think in other places it can be more complicated than this. It usually gives examples and all of that. But yeah, let's go. So moving on, we have the pedantic output parser. So this is where you have a format or an interface, so to speak, that you want your output pass, you want your LLM to respond to you as, you want a structure that is not part of the general types that we have, string, JSON, integer, and all of that. So yeah, I'm defining the class for the model, how I want my LLM to respond. I'm defining a person class, and I'm giving it the fields, the name, the skills, the years of experience, and I'm also putting a field. This field is coming from Pydantic. Pydantic is kind of like what makes it helps, it's kind of like TypeScript. It's kind of like adds that TypeScript feel to Python, sort of, kind of. So yeah, I'm describing what this field should be about. This is going to help the LLM with context, the full name of the person, the skills, list of the person's skills. So LLM knows it's a list that is returning for me. And years of experience, it knows that this place should be an integer, not a string. And then I just define my parser, pedantic. Also, you take this pedantic output parser. So see where this pedantic output parser is coming from now. It's coming from Langchain core. It's not coming from Langchain. So, but you don't have to master all of this. I mean, you can just Google. Langchain has good documentation. So when I pass in this pedantic output parser, I instead of, so before we use JSON output parser, now we're using pedantic output parser. So I say, oh, what's the pedantic object I want? And then I pass this person model into it. And where is the instruction set? Okay, so yeah, I'm printing the format of the instruction. So this is how Pydantic helps you. So it kind of like adds extra instructions to your large language model. So yeah, it's telling it the input should be formatted as a JSON instance that conforms to the JSON schema before. So it gives it like tailored instruction. You don't have to worry yourself about writing all of this. This is the beauty of Python. Of Langchain. You don't have to stress yourself about it. Just import this, define your schema, and it will handle the rest for you. Provide it with example as well. And if you see here, when I run it, so here I define my chain, and here I invoke it. Let's see the result. So you see the result is of type of this class of person that we defined earlier. And that's it about Pydantic. So the Pydantic output parser is used when you have a particular structure you want out from your LLM, probably because you're building something, and it's just like giving your LLM output an interface. For those that know what an interface is, for those that don't know, it's kind of like giving it a structure. And that's all that we covered last week. We didn't do practicals, and I'm happy that we're able to cover that today. And so let's move into what we have for today. What we have for today is very small, and it's something we can brush through quickly. There's enough code as well, but if you kind of like get the whole idea, if I explain it, I mean, you grab everything. You can go through the Google Colab and it's easy peasy. So back to my slides. Yeah. Sorry about the call again. So we've covered this structuring LLM's outputs with JSON parsers, string parsers, and output parsers. Now, what we have for today, lecture 2, the archives, indexing your data. How do you load your external data into your RAG system? This is the core of RAG that I'm putting in my external data into my LLM application. How do you do that? So yeah, it just talks about the importance of indexing, loading the database, so to speak. So we have what is called documents loading. So you kind of like have to impute it, or kind of like have to load it, ingest, so to speak. I say so to speak a lot, but yeah, kind of like have to ingest it, and yeah, Langchain has a lot of document loaders, like a lot, and this is one of the beauties of Python. Sorry, Langchain, there's a lot. I mean, there's a lot of tools that you can use that you're exposed to. So if your data is a YouTube video, Langchain has um, Langchain has a tool, has an object to load your YouTube data. If it is AVIX, if it is in PDF, it is PPT, even if it is a Notion file, if it is something from Telegram, from WhatsApp, Slack, it doesn't matter. Even if it is from data stores like S3 buckets, Supabase, it doesn't matter. It doesn't matter. Langchain has all of that covered. So it's just left to you, depending on what you want to build. Where are you storing your data? You see, they also have for Airtable. It's up to you. It's up to you. And like I said, you can't know everything. Imagine they have for Figma. So let's move on. So next, all right, I'm supposed to do a demo. Sorry, guys, we'll try to finish as quickly as possible. So yeah, let's move to documents loaders. I'm not sure this is in the GitHub, so let me just save it in that GitHub. Let me save it in the GitHub, and yeah, so it should be on the GitHub right about this now. Yep. So yeah, documents loader. So you can see it there. Just open it in Google Colab. So yeah, there's a link at the top. So this link is going to lead you to Langchain site, and proceed. And you'd see a ton of all of the document loaders that I showed you in that image. So see, look, they have the ones for web pages, they have for PDFs, they have for cloud providers. I mean, it's for social platforms, messaging, productivity tools. The list is endless. That's the cool thing about Langchain. And so yeah, I covered this already. So let's run through this. So the normal install Langchain, install Grok. Whatever, too many sessions. Let me close this ones that I have covered. Output here. Cancel. Close. Cancel. Yeah. So I've closed those sessions. Let me run this again. All right, many sessions. It seems I can't open more than. So intro, so let me close these. Let me close these. Let me close this. I hope I'm not deleting them, but however, they're on. Let me refresh. Sorry about that delay. So I hope you guys are learning, and yeah, so from the top, install Langchain, install Grok, get my environment variable. So yeah, I'm installing Langchain's community. Like I told you, all of those external utilities that we use. Yeah, I'm installing PyPDF for loading PDFs. It's a dependency in Langchain. So external things from the Langchain community in particular. Sometimes you might need to install some other external things that are outside of the Langchain ecosystem just to get them wrong. Remember, I told you things from the Langchain community are just maintained by, we, us that have, all those functions we put in our utils folder. Those are the things in Langchain community. So sometimes you might need external stuff to kind of like load it. So yeah, I'm supposed to import a folder. Yeah, this is going to fail because it can't read this. So yeah, I'm supposed to import a folder. Yeah, it should be Langchain PDF, I believe. Yeah. So let me import this Langchain PDF. Okay. So basically what it's telling me is that once I reload this runtime, I'm going to lose this folder. It's not going to be here again. So if I run this again, you should be able to read that folder. So yeah, it has been able to read that folder. And one of the nice things about using documents loader. So we see from this Langchain, we have Langchain community documents loaders, import PyPDF. One of the benefits of importing from this is they all have the same foundational class, which is the documents class. And so for every documents loader that you use in your Langchain application, they have this .load, even if here I'm importing a YouTube, transcript, or it doesn't matter. They have this .load, and this .load is, basically to load the documents that from your file. So if I do .load, this is doc0, I'm taking the first, this is basically like the first page of that document. And yeah, so if you look at here, you see it has this document class, it has the metadata, and it should have, so it has the metadata, and inside the metadata we have producers, creators, blah blah blah, somewhere around here. So you see where it starts with the page contents. So this is everything that is inside that document that I just uploaded. And if I do a pretty print here, and it shows me, the metadata. Metadata is basically information about document that you put into there. And if I want to check the second page, the content of the second page. This is just a simple Python script, and the first 100 characters, this is what I do, and this is what I should get from the second page. And to show you guys that, I'm sorry I'm doing a lot of showing, it's just so we know that joke that numbers start from 0 in programming. So 0. So the second page should be, I think, page 3. Yeah, second page should be page 3. If I go to page 3, so we have Langchain needs providing a flexibility foundation, blah blah blah. And you see that's what we have here. Langchain 3 needs providing a flexible, I just had to crop it. So we also have web loaders. So like I said, some of these tools in the Langchain community needs external dependencies. So this web-based loader is basically like a web scraper, but you don't have to go through all of the, if you've done web scraping, you don't have to go through all of that. Just install Langchain community, install Beautiful Soup. When you do this, then do from Langchain community, the document loaders import web-based loader, and then load web-based. So this is the link to nsq.ai site. So it should load whatever. So okay, when I do .load, so if you notice, so here it's scraping it, so to speak, and here I'm loading the content in script. So when I do that, it should, so it's showing me one page, and I'm supposed to be able to see the content. So let me just do docs 0. Let me see the content. Well, that's taking a while. All right. But yeah, you get the whole idea. yeah, so you see it's showing, page contents, new line, nsk.ai. If go to our website now, you see what that is about. So now when we get this document, as most of you already know, let me close this. So I'm done with this. Next, we're moving to what we call chunking. So as some of you already know, there is context limit for large language models. Let me move this to GitHub. There's a context limit for large language models. So you can't just put in all of your everything, all of your documents, and then boom, inside ChatGPT. There's a limit to what you can feed into it. The same thing with large language models. And the way we mitigate that is through what we call chunking. So after we've loaded our documents, we break our documents down into different parts. We break our, no, sorry, not into different parts, into chunks, so that our LLM can work with those chunks, basically. So we are not like pouring too much into his mouth for it to like gulp down and like, so we are giving it, little chunks to work with based on our query. And next after this, we're going to how do we do that? And yeah, basically we do chunk. That's the whole idea about chunking. You load your documents. After loading your documents, you now chunk it, like cut it down into like little parts. So if I run all of this code is kind of like very explanatory. So this is it. Yeah, I'm using a text loader. This is going to fail because I need to load the text into this place. And that is what is here. So if I load this, yeah, I know it's not going to last. So if I load this, I don't know why this is taking long to do all of this. But yeah, I'm going to load all of this. Okay, I think it's the installation. So yeah, I'm installing Langchain community again. Remember, these are utilities. Utility functions are inside the Langchain community package. So if I do this and then I print this, print length, and it's just one page, and print something is breaking. Let's try this again. Still breaking. Sample data langchain.txt. Well, it's an issue with this. I think this is it. Yeah. Well, all right. Oh well. So, but yeah, if you run this code, you just replace this with your text file, or you can replace this entire thing with maybe a YouTube or whatever it is. The idea is we kind of like whatever. So let me use the file itself. So this is the file. This is what is inside the file. So if I should take all of this and feed it into ChatGPT, if I control highlight all of this and copy it, see how long it is, it's going to be cut off and it's going to lose some of the context. So the idea is I kind of like reduce it. So I say, okay, take this part. This is one chunk, then another part, another chunk. And okay, thankfully I didn't even have to use this. There are two ways you can do chunking. So we have the one we call character text splitter. So what is does character text splitter does? So you define the separator. So you define what you want, what is it going to use as a landmark to decide, okay, I'm going to chunk from year to year. When I get here, I stop. So, and here we are using double new lines, and that means is a paragraph that we're using. And we are defining the chunk size. So the number of characters you should chunk, it shouldn't be more than 200. And there's also what we call a chunk overlap. So when you chunk 200, just take in 20 more, add in 20 more characters, just in case there is anything, that, just so that you don't cut off words. And these numbers, they are not, static. You can change your own to whatever it is, 2000, change this to whatever it is you want it to be. So they're not static, they are variables that you can always change. And yeah, that's what the character. But the downside about this character text splitter, so if you see this was when I loaded in that text document. The downside about this character text splitter is it only works with paragraphs. So if I tell it that for each chunk I want 200 characters, what it's going to tell me is that, so if it takes in 200 characters and maybe let's say it stops here for the 200 characters, there is no paragraph between here. Maybe from the beginning to here is the end of the 200 character. There is no new line here. So what it's going to do is it's not going to listen to what I'm going to say. So it's not going to listen to the instruction I had given it. It will go ahead and chunk everything until it gets to a new line before it stops. So that was kind of like lead it to chunk more than, what the chunk size I decided for it. So it can chunk. And yeah, that was the issue I had in this place. But the standard, but what we use in the industry is what we call the recursive character text splitter. It's similar to this one, only that it's so instead of just doing things based on new line, how it does its own things is that it does it based on paragraphs first. So if you say you want 200, so it gets here and it chunks to paragraphs. It gets here, chunks, okay, I've chunked 200, and then it sees, oh, there are no paragraphs here. It's going to use another what is it called? Another separator, which is lower than this. Is because it has passed that chunk limit. So it's going to use from paragraphs, it moves to new line, and after new line it uses commas and I think punctuation marks, and then after that now chunks, using individual characters as separators basically. So yeah, just go through the collab note and it's like self-explanation. I want us to finish now. We are almost at the end of this. And yeah, so back to my slides. Then we go to embeddings. Yeah, embeddings is the whole call. So after we've chunked, we have to feed it into our LLM. And as most of you might know, machines don't understand human text and all of that. They don't understand human text and all of that. So what it does is there is what we call embedding models. So these embedding models, they take that human text, they take that text that we write, you pass it through the model, and it kind of like gives it what we call a vector representation of those texts. And those vector representation of those texts are just numbers. So take, for example, the word king. When it passed, let's take, this is our embedding model. When it passed through our embedding model, what we now have is 5 for king as a representation of king. And then something like man. When we pass it through our embedding model, what we have is 3.5, and the rest goes on. And then they are basically plotted in a vector space. So when you say something like a graph space, and they're basically plotted in a vector space based on the ones that are similar. So you see the blue ones, what is their coordinates? 4 and 5. You'd see that they are close to each other. The ones that are 2.5 and -2, that is on the x-axis, you see they are also the ones that have minus on their x, they are close to each other. The ones that have minus on their the one that have minus on their y-axis, they are close to each other here, and those that have minus on their x, they are close to each other here. And that is how that is the whole idea of vector embeddings. They are kind of like put together based on their vector, where they are plotted in the vector space. So just see it as a graph. Once this text pass through the vector embedding model, what are the coordinates that it gives it? This is the low level definition. What are the coordinates that it gives? And when I plot it in that graph, it's not a graph, but I'm trying to use it to explain. In that space, where does it stay? If you look at this image, this kind of like defines it better. So when you say something like, so when the text wolf pass through a vector embedding, it's going to be plotted somewhere here, and it's going to be plotted close to dog. And why is it plotted close to dog? Because two of them have something in similar. And what do they have in similar? They are both animals. So they are not going to be very too close to each other, but they're going to be, around the same place. And then something like apple, banana, fruits, they are going to be far because they don't have the same meaning. So vector embeddings are semantic representations of texts in machine learning. And vector stores basically are where we store these vector embeddings. For most databases, you can't store vector, although now I believe there are some databases, but the conventional databases, they can't store vector embeddings, because these vector embeddings, they are not just X and Y, their dimensions. This is a 3D space. So this is a 3 dimension. This is a 2D. But these vector embeddings, their dimensions range from like 300 and something to 1005 or 1002. I don't know, but their dimensions are some. But like, try to think about that. Try to think like a thousand, 1,000 and 1,200 dimensions. Just try to think about it. It's kind of like mind-boggling. And yeah, I provided the code for that as well, but we're running out of time. We're running out of time, and I don't know. I'll just run through the code quickly. It should be inside here. Document loaders should be inside here. Okay, let me just use what I have from here. Vector stores. Yeah, this is the notebook for, okay, this is the one for vector stores. Let me copy this, paste it here. Yep.
Hi,
Sorry.
yeah, we could take questions.
We have questions. All right, let me take questions. I think I'll just push this to the GitHub, run through it. If you have further questions, drop it in the on the Discord channels, and I'll be sure to answer each and every one of them. So Raf, let's take the questions. We've passed time now. Yeah.
Okay,
Thank you.
just one question. It says, can you elaborate on output tokens?
Output tokens. So output tokens are, come give me a minute. So I've put the vector stores. This should be the one for embeddings. So I pushed it to GitHub. So output tokens are they're basically the outputs from your large language models. So last week when we were covering the foundations, we talked about how what we actually send into the large language models are not texts. Mr. Gamma showed us that we send tokens. So before it gets to your LLM, before your LLM can work with whatever you gave it to, it's broken down into tokens. And also, the LLM, when it's responding back to you, what it responds back to you is with tokens. And yeah, that's the whole idea of and then those tokens are now like transcribed into text that you can read. So yeah, that's it. So if you guys don't mind, let me run this. Since it's just one question, let me run through this. Yeah. So there's always a link at the beginning, vector embedding. So embedding models, they're just machine learning models, but what they are for is for converting text into vector representations that the large language model can read and can understand. So if I run all of these, I just need to run this, and we're good to go. Yeah, I wrote some text about vector embeddings. And so where do we get these vector embeddings? OpenAI has their own vector embeddings that you can use through their API, but then it's paid. You have to. So where do we get free ones? We get free ones from sentence transformers. Basically, they have a lot of models, and this is the link. I put the link to their site and documentations as well. Yeah, good. Yeah. They have a lot of models that helps you convert your text into vector representations that that your model can work with. That we can use to do similarity search. So yeah. And if we do that, so yeah, this is where we download one of the, it's usually a big file. So I just want you to know before now, when you're trying to install it, it's usually a big file. And it might take a while for you as well. But when you do it, you embed basically, so you import Hugging Face. Hugging Face is like GitHub for machine learning models. So it's an open source hub where you can find a lot of machine learning models for whatever tasks you want. It could be for language, NLP, it could be for embeddings like this, whatever models beyond just NLP, other areas of AI, you find a lot of open source models on Hugging Face, and they are free. You can download, you can use them, try, fine tune, and all of that. So, and it's from Hugging Face we'll be getting our sentence transformer, and we're also getting Hugging Face from Langchain community. And if you run through this code, it's quite simple. If you're lost, drop it in our Discord. And for those that might be watching the recording, our Discord will be in the description of the YouTube video. So basically, converts your query. It's so when you have a model, it converts your query. Here I'm asking what is the capital of Nigeria, converts it into text representation, into vector representations, a lot of numbers. So I think sentence transformer is taking a while to download. I wish I could show you guys. The parameters are usually like 300 and something. So this was the one I ran before. So the dimensions for each of these vectors. So for this one, the sky is blue. Let's see. Okay, it just showed me the. But yeah, okay, it's finished downloading. And yeah, that's about that. I would have loved to run this, but yeah, we're out of time. So I want to thank you all. Well, it's still up to like, still a good number in this Zoom call. So I want to thank everyone that stayed from the beginning, and I hope you have some clarity. We'll be sending out team tags by tomorrow, Saturday. Yeah, by tomorrow. And I hope you guys, this particular class was, more self-explanatory than the rest. And I also hope you have access to this. Just go to our GitHub repo. You would see all of these notebooks. You can run them on Google Colab in your spare time. You can run them on Google Colab in your spare time. And if you have any question, drop it on Discord. You can tag me, you can tag Raf. So yeah, the embedding model has downloaded. See all the stuff he has to download. And I'm just trying to look for, let me run this live for one. So yeah.
Could you do this some other time so we could close today's session?
All right, thank you. All right, guys.
Thank you for your time. I see some questions on the chat. I've taken note of those questions. They will be answered on the Discord channel, and you could as well, still drop those questions on the Discord channel as well. We meet tomorrow again, right, Ebuka? For
tomorrow we'll have like a keynote from a top engineer. I think if I should be able to like shed more light on that. We have a keynote same time, 6 p.m. West African time. I think it's 8 p.m. East African time.
Yeah.
And then 5 p.m. GMT. If I didn't mention a time zone, I'm sorry about that. I hope you guys can still see my camera. But yeah, we have a keynote. We had one last week, and that was fire as well. So we're having another one, and we're going to have some people from 2 representatives from the team at Langchain. So we're having that next week. I think next week and upper week. One will be giving us a keynote, and the other will be giving us a lecture on monetary. So that's on the ad when we get in.
Okay, I think Ebuka left already. So we could just I would end the session now. Any questions should go to Discord channel, and any other information I'm going to pass on the Discord channel as well as every other channel you can reach us. Thank you all for today. See you later.
Also, one more thing, we're building our first project, first big project next week. So for those asking, yeah, there will be team tags. Please do the team tags, work with your teams. If you don't have teams, fill out the forms, check the Discord to stay updated. Thank you all, and yeah, drop your questions in the Discord. Thank you, Raf.
Hi, everyone. Yeah, so this is a recording for the remaining part of the lecture that we just rushed through, and we were unable to finish it because of there wasn't enough time. So we're going to go through it now, and yeah, I hope so far you've gotten the value and knowledge from the start of the lecture. Yeah, so we're talking about embeddings. We covered chunking, we covered document loaders. Now I'm talking about embeddings. So how do we now, those chunks that we have, how are we now able to retrieve, or in simple terms, how do we find the relevant chunks, since we are going to cut our documents into so many pieces? How do we now find the relevant pieces or piece to our question, to our query? So, and we do that through embeddings, through vector embeddings. So what are vector embeddings? Vector embeddings are crucial for transforming text data into numerical spaces. They help in capturing the semantic meanings of words and phrases. This allows for better data retrieval and indexing in various applications. So basically what embeddings are is our text data was converted into what we call, you can see they are an arrays of numbers, but what they are in simple terms are numerical representation of what those texts means. Do you understand? So let me go through it. Yeah, so let's use this video. So take for example this image. We have the word king. When the word king passes through what we call an embedding model, so we have embedding models, and these are just machine learning models that their function is to convert text into numerical representations, to give numerical representations for text. That is what embedding models are. So they're a type of machine learning models. The same way you have large language models, those ones they are for generating text, also processing text. You have other models in different areas. We have vision models and all. This embedding models are for converting text into what we call vectors or embeddings. And yeah, this is king. When it passes through the embedding model, what do we have? 4, 5. Now this is not the exact representation, this is an illustration. So here you see that this is like a 2D space, and there's the x and y, so to speak, axis. And then we have the man. If a man passes through this space, it's going to have 3 and 3.5. Now what does this mean? So you see king and man. So this is 4 and 5. I'm believing 4 is the x-axis, so this should be around here, and 5. So this is king. Let's assume that this is king. And then you see the one for man, 3.5. This is his own distinct representation. So this is where the man representation is most likely to be. What you'd notice is that this king and man, they are close to each other. And why are they close to each other? Because they have similarities in their semantics. So semantics just means meaning. Is big English for meaning. So they have similarities in their meaning. So And you would see, because yeah, a king is a man and a man is a male. You understand? A king is male, a man is male. So they are likely, even though they don't mean 100% the same thing, they're sort of going to be in the same neighborhood. So let's say another thing for maybe a word like ruler will be somewhere around here because it's closer in meaning to a king. Do you understand? And yeah. But look at woman. In as much as it is in the same neighborhood, it's a bit farther from both the king. It's far from the king and it's far from the man, and farther from even the king, because it's not close. It's similar it's not so close in meaning to it, but then they're in the same neighborhood. What neighborhood are they in? In the neighborhood of human beings. So these are humans. Do you understand? So this is the space. Remember, here it said transforming text data into numerical spaces. So this is a numerical space. This is where when they pass through the embedding, this is where they will be plotted on the graph. But look at something like apple, banana, orange. Look at where they are plotted, far from this place. Why? Because they don't have common. Their semantics are far. They are apart. They're not close in meaning. Yeah, they're not so close in meaning. In as much as these three are not the same, if you look at it, they're in the same neighborhood. So let's say this is the neighborhood for fruits. So say something like mango will be around here, or something like pineapple, whatever. It's going to be around. But you see how far they are from this. So when they pass through the embedding model, they kind of get what we call they get their vector representations, and to put it in simple terms, let me call them coordinates, because since we're saying they are going to be in vector spaces, let me call them coordinates so that you can easily understand it. And then they are plotted so they are plotted in that vector space. This is an example. This is a 2D space. They are plotted in that vector space, and each one is plotted in the vector space according to the neighborhood they are in, and they would also have texts that have been plotted into the vector space that are similar in meaning to them. These ones, they are similar because they are fruits. Here we have football, golf, tennis. So you can just say this place is for the ones for sports. I don't know if you get what I'm saying. But then I want you to know that vector embeddings are not just an array of two numbers or coordinate of just x and y. Their dimensions, and when I say dimension, 2D, this is a two-dimension space. This is a two-dimension space because it has just two axes, the x-axis and the y-axis. So their dimensions for vector spaces range from like 300 and something to like 700. There are some models that have I think 1,500 or 200. So it depends on the embedding model that you're using. Again, it depends on the embedding model. So yeah, that's embedding models help us give numerical representations for this. And somebody might ask why we have to use embedding models. I believe it's because computers work best with numbers. Do you understand? They don't see words the way we human beings see them. Machines, they work best with numbers. And that's why we have to give these numerical representations that the same way they taught you in primary school or wherever they taught you that when a computer doesn't understand English, everything is converted to zeros and ones. So yeah. And this is just another example. This is a three-dimension space. So we have the y-axis, we have the x-axis, we have the z-axis. But this is a three-dimension space. So you see where if these vectors were three-dimensional space. You see where the wolf, dog, cat are. See, they're in this same neighborhood because they are all animals. But look at banana, apple. They are far. Why? Because they are fruits. They are far in where they are plotted in this space. So, having done that, let's get into the code. Sorry about my coffee again. So yeah, I dropped in the notebook the start. I dropped documentation to what's it called, Langchain's docs for vector embedding. So you can go through it and see there are different embedding models. There are so many embedding models here, from OpenAI, Llama, so many of them here, so many. However, most of these are enterprise, and I believe most of them here are paid for, except maybe Google. And some of them, I don't know, it depends. But we'll be using a free one. So I've gone ahead to run all of this so we don't waste time on this. So we pip install Langchain. I installed Langchain for Grok, set up my environment variables that has my Grok secret key, install Langchain community, install Langchain text splitters, although we won't be using that here. And then I dropped a piece of notes for you to like get. So and I installed sentence transformers. So sentence transformers so I put in a link to the site here. So what is sentence transformer? So it's just a Python repository or Python package, let me see, that has so many models. So it's a Python module for assessing and using state-of-the-art embedding models. So they have a lot of embedding models here, and through sentence transformer you have access to access all of that. So if you want to find them, just once you hit their website, come to pre-trained models. They have this small example on how to use their stuff. And here you have a list of models, and there are different metrics. So depending on what you want, you can now choose. So pick the one you want, and then you can copy the text here. And yeah, so yeah, I'm using this one for this, and I think this is where it is. This is the one I'm using. All right, so let's run that. So then I also talked about Hugging Face. Hugging Face is like GitHub for machine learning models. So it's an open source hub where you can get access to so many models. So huggingface.co, and so many models are deployed there. You can access them for free. It doesn't matter, like it could be text models, language. It's not limited to large language models. There are vision models here, and all types of machine learning models. Alright, so let's get into it. So how do we use embedding models in Langchain? So first we do from Langchain community.embeddings import Hugging Face embeddings. So this will just allow you to use this is like an interface to interact with Hugging Face API. So we initialize the embedding model, and then Langchain will download the model from Hugging Face and cache it. One of the beauties of Langchain, download stuff and cache it for you. So yeah, I'm just defining the model I want to download from Hugging Face, sentence transformers / all, the name of the model, but I have to like start with sentence transformers, then / because I'm getting it from Hugging Face. And I define my embeddings, and I run Hugging Face embeddings, and then I pass in the name of the model. Model name is equal to model name, yeah. And Hugging Face is going to go ahead and download. So this is going to go ahead and download this embedding model from Hugging Face from me. So this is what it's going to download. Mind you, it's like a lot of megabytes. I don't know how many this one was. I think this was 90. I don't know, but yeah, it's usually a lot. That's why you had to like load everything beforehand. So yeah, so next thing, embedding a single piece of query. So here we've defined our embedding in Langchain. Here this is where we defined our embedding. And now what do? If we want to embed a single piece of text, so example is a query, just one text, what is the capital of Nigeria? The query vector, so we just do embedding, we call that embeddings we define, and we use the .embed query method and pass in the text query we want to embed. And if we run this, okay, so if we run this now, this is what we get. So this is just a short text, right? Embedding for a single query, first 5 dimensions. So look at the array, the first 5 dimensions of this query. What is capital of Nigeria? This is like the first 5 numbers that is like a representation of this text. So you see there's 0.08. So you look at all the numbers and the embedding dimension. So yeah, I said length of the array is 384. So it's like a 384 space, numerical space, 384 dimensions. So if I should, just to show you what the entire stuff looks like, if I should run this again and without this, so that we can see like the full stuff. Let's run this again. This Python warning. So yeah, cleaner now. So see, so look at, it's a lot. So all of these numbers in this array, they're kind of like an array, but we call them vectors. They are what represent the text, what is the capital of Nigeria. So once you want to embed a single text, we use the .embed query on where we've already defined initialized our embedding. But what if you want to embed a piece of documents? Remember, when we chunk our documents, we usually get them like back in a list of chunks. So how do we do that? Let's say this list here, it's a chunk that was embedded. Sorry, let's say this list here are from documents, is from a document or documents that were chunked, and each of these elements is a chunk. How do we do it in Langchain? How we do it in Langchain is we call that same embeddings that we defined, and we call the .embed documents. We call the .embed documents method and pass in that list of chunks. So you see, it's simple, no hard stuff. No need to go through, what's it called again? Loops and all of that. Like Langchain is going to handle all of that for you, which is one of the beauty of working on Langchain. So we say print. So let me print number of documents vectors. Let me first of all. So this expression is going to return us a list, and that list is going to have the array for each of the embedded documents. So let's run this, and you see number of document vectors, we have 3, and let me print the first dimension for each of that. So dimension for the first document vector of talks 0 and the first 5. So I'm printing the first 5 for each of them. So you see, this is what they look like. If I should say, if I should remove all of these and just print them like as they are. Oh, sorry. So my bad. I shouldn't have. It should have been 0, 1, 2. So, but then look at it's two lists. So this list is the first embedding. But if I run this, yeah. So that's that on vector embedding. So now let's move on to the next thing, vector stores. What are vector stores? Vector stores is just the database where we store vector embeddings. So your typical databases, a good number of them cannot store vector embeddings, and even if they could, they were not optimized for that. That's not their purpose. They were not built for that. So I don't believe that they'll be as efficient as vector stores. But in the AI engineering space, in the RAG space, we use vector stores. And yeah, they're just, in simple terms, they're just where these vector embeddings are. And they enable quick search and retrieval of high dimensional data. So they are optimized for quick search. So when you want to do a similarity search between your query and loads of chunks that you have, they're optimized to search through all of that, do that similarity search quickly, and get you the most similar ones as well. So they allow advanced indexing techniques, enhancing the search experience for users. By implementing the vector stores applications, we can achieve faster response time and better results. So let's get into the code. So it's just a place for storing our vector embeddings. Oh, and I forgot to mention, this is the repo. If you get into this intro to Langchain notebooks, you'd see all of the notebooks that we've been using. This is the link to the repo. It will be in the description of this video as well. So let's get into it. So vector stores. So I've gone ahead. So I put, once again, I put a link to Langchain's docs on vector stores. You see so many vector stores here. The one we'll be using in this vector, so you see a lot of them. But the one we'll be using in this lecture would be what we call an in-memory vector store. More on that later. So pip Langchain, I've installed Langchain, installed Grok, set up my environment, installed Langchain community, installed Langchain Hugging Face, installed sentence transformers, installed Fire's CPU. So Fire's is an in-memory vector store. So we can just run a vector store on our PC. So that's what Fire's is for. So, and then I've gone ahead after installing Fire's. Fire's is the name of the memory vector store we're going to use. I installed a lot of like packages, PyPDF, unstructured, payload, and I installed it because of the document loader we're going to be using. So during the lecture, we used a PDF loader, a PDF documents loader. Yeah, we're going to be using another PDF document loader, but this one now is an online one. Remember that one, we had to access our directory. Now on this one, you don't have to do that. And yeah, it's led me to installing. So usually Langchain text splitters is okay, Langchain community is okay, but you remember I said some of the tools from the Langchain community need some other external, they are dependent on some other external packages, and we have to install all of them. But I actually believe that if I had only installed this line, I mean, you guys can try it out. If I had installed just this line, I wouldn't have had to install all of these, extra things. But yeah, it's the requirement of this online PDF loader. So unstructured is another documents loader, and it's basically used to load any type of document at all that doesn't have a particular structure. So HTML, PDF, text, whatever. Yeah, it's like a hybrid or something. So it's not just for one type of loader. All right, so we're using the online PDF loader, and the online, sorry about that, excuse me. And the online PDF loader basically loads PDFs from the internet. So I have this, if you Okay, so I have this PDF on online. It's not mine though. So it's about Ethiopian culture. Yeah, in this bootcamp we have a lot of Ethiopians, like so many. I think almost 500 or so. Like a lot of Ethiopians, and noticed they're really cool people. They have they have like good sense of humor as well. So, and yeah, I think they coordinate themselves well as well. So, yeah, kind of like Ethiopian. Shout out to all the Ethiopians. So yeah, I decided to like use something about their culture for this lecture, right? So if you look, this is the site. It's a PDF of 72 pages about Ethiopian culture and how amazing they are. Yeah. So if you're interested in Ethiopian culture, you can take it out. So back to our notebook. So how do I now load this into my vector store? How do I load this and then convert it into vector embeddings, then load this into my vector store? So what do we do? From Langchain community, import document loaders. Then I import this online PDF loader. Note this is different from the one we used, which was a PDF loader. I think that's what it's called. Yeah. So yeah, I define the URL I want, and then I load the PDF with the online PDF loader. This is redundant, so I'll comment this out. And then when I load, so then we say loader equal to online PDF loader PDF. So here it's going to load it, and the rest. So and then now I do the dot load. This dot load method is going to fetch and pass the PDF. Remember I said every document loader implements the document class from Langchain. So and the document class has the dot load. So it doesn't matter if it is a database loader or a web loader or a document or a text or a CSV loader, is going to have the dot load method. So you can always count on that. Shout out to Langchain once again. So so when I load this, is going to fetch and pass this PDF. Now one thing about this online PDF loader is, unlike the regular PDF loader, it's going to load all of your PDF in one page. So the regular PDF loader is going to like load your PDF according to the pages your PDF documents has, but this online PDF loader is going to load everything in one page. So all these 72 pages, everything are going to be in one page, and we can confirm that when we check the length. So you see here, I'm checking the length of the documents, and it says loaded one document from the URL. So it has converted all of those 72 pages into one document. Now we go ahead and split it. So we go from Langchain text splitters import recursive character text splitter. This is redundant. So yeah, I define my text splitter, recursive text splitter. I choose the chunk size. Remember I said chunk size, the amount of characters we want for each chunk, and then chunk overlap 150. And yeah, so we say chunks equal to text splitter dot split documents, same method. So we pass in the document we want to split, and let's print the length of the chunk. So we see how many. So this is typically going to give you an array. So this is typically going to give you an array of chunks, like I showed you in this vector embedding here. So back to this. So let's check how many chunks we got. We have 100, split the document to 125 chunks. So now next is, this thing failed. No, this is going to take time. Okay, since I'm recording this, I guess I can pause this and come back. But while this is loading, let me just explain this. So after we've gotten our chunks, and they're stored inside this chunks variable here. After we've gotten our chunks, next we import from Langchain Hugging Face, import Hugging Face embeddings. So this is just so use embeddings from Langchain, and then we import our vector database files. So here we do what we did before. we define our embedding model that we want to use, and here I'm using a different embedding model. I already showed you guys how to get different embedding model, and then we have the DB. So here I'm defining my vector store. So I just saying fires dots from documents, passing the chunks that we got, and I pass in the embedding models I want to use to embed those chunks, and that's all. That's the beautiful thing about Langchain. So what is happening here? So you see where the green stuff is. It has downloaded the embedding model, and now it is just embedding, is sort of like looping through each of the chunks, embedding them, giving them vector representations, and then indexing them into the vector store in our memory. So at the end of this, it's supposed to print the vector store has been created. I'll just pause this recording and come back to when it is done. So we're back. So that ran for 2 minutes. It took a while to index all of that. So it's also going to embed the chunk, then index them into the database. So our database has been created. Now, if you want to, so yeah, if we want to do like a similarity search in our database, what we do in Langchain is you go the DB that you initialize dot similarity search, and then you pass in the query. What is the role of family in utopian society? Pass in the query and define k, any number you want. So what's k? So this similarity search method is going to take this your query and go through the database and do a similarity search through the database. So which of the documents that I have embedded in myself, so which of the documents that has been embedded in the database is similar to this, how many of them are similar to this query. And this case is just saying return the top 3 for me. So if you want, you can turn this to 5 and it's return that for you. It's up to you, but it's going to return the top 3 that are closest in similarity to your question. So if I run this and then I print the results, so you see the top 3 results are result 1, this is the content, roles and centers of authority, local organizations, blah blah blah, religious networks cared for needy, it's a household. Well, this line says family including extended family is important. Having children is an important part of a utopian social life and increases a woman's prestige. On average, a woman has 6 children. Children are often called upon to support their elderly parents because of the importance on extended family and the highest status for women who have large numbers of children. Ethiopians tend to marry early and have large families. So I like the idea of marrying early. So yeah, that's so the next one, you'd see it's higher status for women, family ties remain significant even across vast distances. That's the nice thing. I told you guys, Ethiopians are really cool people. So yeah. This, so you see, it's returned documents that are close and similar to my query, and that's just everything about vector stores. You see, it's easy to search through it. There isn't a SQL query or any other stuff. That just use this method. And another shout out to Langchain. They kind of like make building AI applications like really easy. I mean, it's where they say attention is all you need in large language models. I think in AI agents, Langchain is all you need. Yeah, because they have everything. We talked about Langchain, Langsmith. Langsmith is a observability platform. They have Langserve. We have Langgraph, building agents. Langchain coming. Oh, Langchain is a law. So yeah, shout out to them. All right, next I'm building a RAG chain. So let's put everything that we've learned so far into practice. So yeah, I'm building a Langchain. So from Langchain core prompt, I'm importing my chat prompt template. I'm importing chat grok, that is for grok, my output parser, and runnable parser. So running parser is another type of runnable. So yeah, remember I told you there are so many runnables depending on your use case. So yeah, I defined my template. Answer the question like an Ethiopian young guy based only on the following context. So I'll pass it the context placeholder here. This is the question. Note, use popular Ethiopian slangs. Alright, so here I'm telling you to use popular Ethiopian slangs. So let's see how that goes. And here I define my prompt template, charge prompt template from template, and then I pass in my template. And then I initialize my language model, and you have to make sure that you have your Grok API key in your secret environment or in your environment variable, depending on where you're running this code. So I'm using the Llama 3 8B model, defining my output parser, and yeah, I run through the steps for my RAG chain. So the chain will take the user's question, pass it to the retrieval, vector store for similarity shares, pass the retrieved documents and original question to the prompt template, pass the formatted prompt to the LLM, and pass the LLM's outputs. Alright, so yeah, this is the context, this is the dictionary I'm passing first in the chain. So this is the context that will be passed into the prompt. So how do? We just do db.asRetrieval. This is just going to basically a retrieval of the documents that are similar to my query, and I have the question, and here we have the runnable pass-through. So what this runnable pass-through is basically going to do is just going to pass that question variable onto the next one, without mutating it or doing anything or losing it. It's just going to pass it through the next person from this chain. Alright, so we have the prompts. So when all of this is passed into the prompts, it gets into the LLM, and LLM generates my answer, and then the output parser cleans that up. So let's run that, and this is where we get busy. So this is the question I want to ask. What is the role of family in Ethiopian society? And then to use this RAG chain that we've built here, you just do RAG chain dot invoke and pass in a question, and let's see what we get back. So you say, why family is like super important in Ethiopian society, sounds like Naruto. It's like the foundation of our culture and everything. We Ethiopians, we value family ties. You feel me? See, I told you guys Ethiopians are fun. Imagine, see how they even talk. I hope this is correct, but yeah, we got this thing called extended family, where we got our immediate family, and then we got our cousins, aunts, uncles, and all that. It's like one big farm, and having kids is like, so I notice is they use like a lot of it's like a big deal for us. We want to have a lot of kids, like 6, it's like, so yeah, and that's it. So I hope you guys found value in this. I hope you learned. If you have any questions, drop it in our Discord. If you have any questions, drop it in our Discord, and that will be all. The rest, so how do we optimize vector stores retrieval? That will be handled next week. See you next week. And what else? Alright, yeah, we're supposed to do question and answer. I think we handled like one question or so that day. But if you have any further questions, drop it in Discord. You can tag me on Discord. I would respond. And yeah, this is me, Chukwuebuka. I think this was the part I was showing at the start of the recording. I was just talking about myself. I didn't know that my slides were not showing. But yeah, that aside, yeah, I'm the Bootcamp lead, and I'm AI lead. You can connect with me on LinkedIn. And yeah, see you guys. Thank you. I'm so happy for those that are always posting. I see a lot of people tag me in a post. Yeah, thank you so much for that. Yeah, you can do more of that. Share your journey, learn in public, let people know what you're on to, so when opportunities come their way, you come to their mind. So yeah, you can tag me in your posts. I'll be sure to repost all of them. And yeah, that's all. I'm so happy that I see that a lot of people, saying they got some value. So I hope that a good number of people are getting value, and we are able to break down all of these complex concepts into ways you can understand even as a beginner. So cheers, have fun.